Hi everyone, this is my second time recording this kind of thing, so please bear with me for any hiccups here and there. Okay, so what we are looking at here is an email from Only. He asked me, Carol, and Kander to present a brown bag about clean architecture. And 1 year and 6 days later, today, here is the brown bag. This presentation is brought to you by Ping Android team. We have many lessons about architecture that we learned during the development of KASKUS Chat, especially on Android platform. And we hope we can share it with you all in this presentation. Let's start with the title itself, Clean Architecture. Most of you must have known about this article. It's pretty famous. It was probably the first time Uncle Bob coined the term clean architecture, and it was in 2012, 6 years old by now, but it was not the first time someone came across with some name for architecture. Before clean architecture, there was hexagonal architecture by Alistair Cockburn. Some people refer to it as ports and adapters. And there's onion architecture by Jeffrey Pallermo. There's also DCI and PCE. And then finally, Uncle Bob came out with clean architecture. And interestingly, all of them, although they differ in name and vary in details, they have all the same characteristics. That is, they are independent of any external agencies, be it frameworks, user interfaces, or databases, and obviously it's testable. I will not deep dive into each of them in this presentation, and for simplicity, I will only use the diagram of clean architecture from Uncle Bob. Before we go even further, I first want to clear out any potential confusion with this. Some of you should have known about this. It's the various software architecture patterns from O'Reilly Software Architecture Conference in 2017. They have these 7 architecture patterns. So how do they differ from the previous architectures we're talking about? The O'Reilly architectures are describing block diagram, while the previous ones, hexagonal, onion, and clean, are describing dependency diagram. I hope this clears out any confusion, and we will not be discussing about O'Reilly architecture patterns here. We will only discuss the clean architecture one. Okay, let's continue with this term, software. As the name suggests, software was invented to be soft. What does soft mean? Software is soft means that it should be easy to change, because if it was hard to change, we would have called it hardware. It makes sense, right? It's hard to change a microwave into a cell phone. Well, it's possible, but it's hard. However, it should be easy to change a messaging app into a financial technology application that can send you money. So, every time you find yourself thinking that it's hard to change your code, maybe you should ask this question: am I making a software or hardware? Now, how do we make software soft? It's by leaving as many options open as possible for as long as possible. It's a quote from Uncle Bob. What options are we talking about here? It's the details that do not matter. For example, databases. For your architecture, it should not matter if you use MySQL or Postgre. I/O devices. It doesn't matter whether you use punch cards or magnetic tapes or hard disks or cloud. Servers. AWS, GCP, even on-premise. It should not matter to your application. You should keep your options open. Now, how do we keep our options open? The answer is actually pretty simple. We have heard it over and over again. I'm sure some of you have gone super bored hearing this solid term. But worry not, my friend. I'll do my best not to be just another slides about solid. Also, I will only talk about interface segregation principle and dependency inversion principle. I will not talk about the first 3, and you will see why. Dependency inversion. Why is it so important? Let's talk about the simple copy program. You declare a variable named C, and then you get car and put it until the end of file. Let's take a look on the inside of getCar. It's also pretty simple. It invokes the read function from a pointer named standard input, stdin. And what is the standard input? It's a pointer variable pointing to a file struct, and it was given the address of console. What is console? It is an implementation of file struct, and it has these 5 functions: open, close, read, write, and seek. And if you see this file struct here, they have these 5 pointer to functions. Now the interesting part is we can swap this standard input with another file struct implementation. The way we read and write to punch card is different with that from magnetic tapes or disk or even the AWS cloud. But the copy program is still the same. The algorithm is the same. It's the same copy program, but with different I/O devices. We have learned to make the reader and the writer to depend on the copy program and not the other way around. So why do we bother to make this kind of pointer to functions just for this simple copy program? Because we have learned that we need the same program, the same algorithm to run with different devices, be it punch cards, magnetic tapes, then floppy disks, compact disks, flash drives, and now the cloud. And you see, this source code was written in C, so the concept of dependency inversion has been there since the 1960s, even in a non-object-oriented programming language. The copy program is a simple example to give you the idea of a more abstract and higher level concept that is dependency inversion. Every program or application or system has these 2 kinds of arrows. The dotted green one showing the flow of control or the flow of data in your system, and the red one showing the source code dependency. Usually, both of them are pointing in the same direction, just like this diagram. But with dependency inversion principle, we can invert the red arrow, the dependency arrow, every time we want, and everywhere we need it. And we can do it thanks to the power of polymorphism. In Java programming language, you will use interface or abstract class to do it. Just like how we make the reader and the writer, in this case the console reader and writer, depend on the copy program here. But it's written in C. C doesn't have interface. Oh yes, that's correct. C doesn't have interface. This file struct is the interface. These pointer to functions are the interface. And that's the beauty of it. The concept of dependency inversion does not only apply to modern programming language, and certainly not only for object-oriented ones. It's universal. Now, okay, we can invert the dependency direction every time we want, but what are the benefits? Why do we want to do it? For the copy program, we have seen the benefit. We don't need to recompile the copy program each time we have new I/O devices. So what's the abstraction of this? What's the higher level benefits? With dependency inversion principle, suddenly you can develop your business rules independent of any user interface, independent of any databases. Remember, UI and databases are details that do not matter. These business rules here are the ones that matter. And if you can develop it independently, then you can also deploy it independently. And guess what? The concept of independent developability has also been there since the 1960s in the Apollo spacecraft design. It says, minimize functional interfaces between complex pieces of hardware. In this way, 2 organizations can work on their own hardware relatively independently. And that is independent developability. It's been there since 1960s. Can you imagine? if the dependency inversion principle can be applied on hardware, there's no reason we cannot apply it on any programming languages. Okay, that's dependency inversion. Let's switch to another topic, library versus framework. Don't worry, it's still related. So what's the difference between library versus framework? To be able to answer that, let's observe some snippets, some code snippets. Observe the C++ program. It includes the IOStream library and string library, and it prints the hello world, what's your name, and then it will wait for user's input, and then it will print out your name is blah blah blah. Then observe this PHP code. It's using Laravel framework, user controller, extends controller. There is this method show, and then we define a route to this controller. Java programming language using Android framework, chat fragment, extends fragment, and then we override this many method. Same thing with Swift, extending UI navigation controller, and we override some methods. Java Spring, a little bit different. We use this annotation, add controller, and add get mapping. And there is also this ES6 ECMAScript 6 source code using React framework. Clock extends react.component, and then we kind of override these methods. So, what's the difference? What's the relationship within your code library and framework? This diagram nicely summarizes it all. Unfortunately, I cannot find the original creator of this diagram, so I cannot give proper attribution. Your framework calls your code. Your code calls the library, and sometimes framework contains library. Now, this is a problem with definition. If we refer to this diagram, it should be obvious that React is a framework because the React framework will call this method. We do not call this method ourselves, but it will be called by React framework. But the official website of React.js clearly states that it's a JavaScript library. So we're not going to discuss about that in this presentation. I will leave it up to you whether you think React is a framework or a library. So in a few words, the defining characteristic of a framework is this term, inversion of control. The framework calls you and not the other way around. From inversion of control, the term evolves to become dependency injections. You can check about it more on this article by Martin Fowler. Okay, that's a lot of theory. It's now time to share with you about KASKUS Chat implementation. And I'd like to remind you that the implementation might not be as idealistic as the theory. When we go from theory to implementation, sometimes we have to be practical. We have to be pragmatic. This is a picture to give you an idea about KASKUS Chat Android dependency diagram before and after we grasp the concept of clean architecture. As you can see, it looks like spaghetti code, circular dependencies here and there. Now, since the very first beginning, we have been using the boilerplate code from Android 10 GitHub. It's Android clean architecture boilerplate code, and there are these two pictures in the GitHub. Pop quiz. If we perceive this diagram on the left one, as a dependency diagram, which arrow do you think is the correct one? Is it A or B? Just by looking at the layer names. So it's presentation, domain, and data. Which one is the correct dependency direction? If you haven't decided on the answer yet, you might want to pause video because the correct answer is B. It's the below one. The boilerplate code from Android 10 was inspired by Uncle Bob's diagram of clean architecture, so it should be safe to use it. If we use it, we will definitely conform with clean architecture, right? Right? Well, turn out it's wrong. We learned that it's really dangerous to use something that you don't really understand yet. This is the first iteration of our dependency diagram. The left one is the diagram we think we have. Presentation depends on domain, and domain depends on data. The sad thing is that it's wrong. And even sadder, the reality is even worse. Our dependency diagram on the first iteration was actually look like this. Right one. It's circular dependencies everywhere. This is the correct dependency diagram that is also our second iteration. The domain is like the business rules. Presentation and data is like the UI and databases. It's similar to this diagram we've seen before. The dependency arrow should point inward into the business rules. And this is a more complete high-level view of our dependency diagram compared to clean architecture diagram from Uncle Bob. From the innermost layer, we put entities and use cases into one module, that is domain module, and then the presentation and data both belong in the same layer, the screen layer. And finally, the outermost layer, that is the details that do not matter, Android Fragment, ORM Lite library, and SMAC framework, all of them are on the outermost layer, the blue one. And all of them point inward. Domain doesn't know anything about presentation and data, and cascadingly, it also doesn't care about Android Fragment, ORM Lite, or SMAC framework. Previously, we know that there are two benefits of using clean architecture. Those are independent deployability and developability. I'd like to add one more benefit. Using clean architecture, we will be able to easily swap or upgrade our third-party dependencies. This is one real example. In KASKUS Chat, we treat SMAC framework as a detail that doesn't matter. We put it on the outermost layer. On our domain module, or you can say domain layer, we have this group chat interface. It contains the contract related to groups, how to create, join, exit group, etc. And then on the data layer, we implement the contract using a SMAC library. Pay attention to the import lines here. On domain layer, it's only 6 lines, while in data layer, it's 35 lines. It makes sense. Our domain layer doesn't need to know about the details, while our data layer is where already the details are implemented. The class from SMAC framework that we use to implement group chat is this one, smacx.muc.multiuserchat. And it's only imported in just a few classes. In fact, in this case, it's only in one class, this SMAC group chat class. Then one day, SMAC decided to upgrade its version from 4.16 to 4.18, and it contains breaking changes. The way it creates group is now different, so we have to change the implementation. Had we not used dependency inversion principle, the multi-user chat usage would have been everywhere, and it surely will take much longer time to upgrade it. Other way to view it is like this way. Let's say we deploy our system using cloud in AWS, and then a cheaper alternative comes up, that is Google Cloud Platform, GCP. We should be able to swap our deployment system to GCP without touching our business rules, because no matter where we deploy our system, our business rules stay the same. Okay, let's move on again to the next topic about flow of control, how its components communicate with each other. And it's talking about this little diagram on the bottom right corner of clean architecture diagram. So, about the use case interactor, we have this abstract class named use case. It's a template class. You have input and output. And we have abstract method with use case flowable, and we have public method execute here. It receives two parameters. The first one is subscriber, and this is a interface. This is an interface from another library, RxJava, and about RxJava, it's a whole another discussion. For now, we only need to know that it's an interface, and this subscriber will be our output port, so this one. And the second parameter is the input. And then we extend that abstract class use case into the implementation detail. For example, this one is load more message use case, and we have this the input is get message param. It's a class. This will be our input port. We also implement the abstract method from before, the put use case flowable, and the inside of this is our unique algorithm. And then we have this presenter class, chat presenter. Pay attention to this method, load more message. Inside of it, we execute the use case, the load more message use case. And for the first parameter, we implement the subscriber interface here from before, and we expect the output to be list of messages. And if you look closely, the arrow here is pointing to the arrow between presenter and the use case output port. So it means this is the implementation of this use case output port. And then for the second parameter, we instantiate this get message param as our input port. And finally, we have this fragment class. Remember, it's Android specific. It's in the outermost layer. And if you look closely, we inject the chat presenter here. That means we also inject all subsequent dependencies on chat presenter, which includes a lot more message use case, obviously. Also, we have this chat view. This obviously an interface that is implemented by this chat fragment class. And the chat view interface itself is used in chat presenter. So we need this interface, we need this chat view interface to invert the dependency, so it will be chat fragment that depends on the chat presenter and not the other way around. And so our flow of control begins here. You can think of this chat fragment as our controller, this green rectangle here. The user clicks a button, and then the Android framework passes the event to our onload more button click. And then we invoke this one, presenter.load more message. It will invoke the use case inside this presenter, and then the use case will return the output to the presenter via the through the use case output port. There is subscriber, and then it will call the onNext method. So we will have the list of messages, and then the presenter, this chat presenter will pass the output to the view. This one, view.addMessages, and the view will show it to the user. Okay, so we know the previous explanation is just one way to interpret clean architecture flow of control. So take it with a grain of salt. It might not be applicable to your use case. And the explanation might be a bit confusing, so if there is anyone who want to take it offline and discuss it with us, feel free. Okay, moving on. Our next topic is the SDK. It's not enough to confuse us with library versus framework. Now we have SDK. So what do you guys think about the difference between library, framework, and SDK? Well, we will not discuss about that in this presentation. We will leave it as an exercise for you, the viewers. Okay, SDK, one step further from library versus framework. Previously, we have discussed KASKUS Chat dependency diagram on first and second iteration, and now this is our third iteration. The background why we designed it this way is quite simple. We want to embed KASKUS Chat into KASKUS Forum app. Now, as a great software engineer, we have to be able to understand the abstraction. The requirement is not just embedding KASKUS Chat into KASKUS Forum, it's embedding KASKUS Chat into any application. Moreover, there will be two kinds of application. One, the applications that will use whatever UI, whatever look and feel we have. And two, applications that will use only our business rules because they have their own unique UI. The first type of application will use our SDK UI, and the second type will use our SDK. We decided to separate them into SDK UI and SDK because the UI is quite heavy on storage, and we don't want applications that don't actually need our UI to depend on things they don't need. Also, we kind of dogfood our own SDK and SDK UI here. So our KASKUS Chat Android app is actually a third-party application. This one. Its only concern is logging the user in. Just it. Everything else will be handled by SDK UI. And as SDK UI depends on SDK, it is automatically dog-fooded. I don't know if it's the right term, dog-fooded. Well, anyway. Well, this is the third iteration. So previously we only have presentation, data, and domain. Now SDK UI depends on presentation. It makes sense because the UI will need presenter. SDK will only depend on data, and everything else stays the same, except that we move this Android fragment to be inside the SDK UI. And to simplify the diagram, take a look at these two boundaries, the purple and the blue one. We have SDK boundary and we have the core boundary, like this. And to simplify it even further, we can view it like this. So we have SDK and we have core. That's it. Well, it looks this simple if we look at it from this point of view, but to achieve this simplicity, there are actually a lot of complexity that we hide under the hood. So, well, designing an SDK could be another discussion by itself. Moving on again, next topic. Thou shall not marry the framework. The term marry here means your business rules depend on the framework. So you put the framework in the innermost layer. Based on clean architecture concept, framework is one of many details that do not matter. So we should not marry them, right? Well, previously we explained about being idealistic versus being pragmatic, and this is the other time for us to be pragmatic. This is a real case on KASKUS Chat Android. Our domain layer depends on RxJava library. We got married with RxJava. And this is a conscious decision. We decided to marry it. Why? Because making abstraction for RxJava is just not worth it. RxJava itself, in our opinion, is already abstract enough. So this is, again, another example that you should take everything with a grain of salt. Every system is different. It's our job as a great software engineers to decide which trade-off we have to take. Next topic. Wow, we have a lot of topics. One interface, one implementation. Is it overkill? Some of you might have run into this kind of problem. You find yourself with a lot of blah 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 IMPL class. It's quite a lot to the point you ask yourself, there's only one concrete class for its interface. Why would I need to make the interface then? It's so much hassle. This is one example. Pay attention that we have a login presenter interface here, and it's implemented in login presenter IMPL. And if you look closely, they both are in the same package, the presenter package, and so are the others. It happened on KASKUS Chat on our first iteration. Now, is it overkill? Well, the answer is no. It's not overkill to have one interface and one implementation. However, if they are on the same package, you might want to revisit your dependency diagram. This is our second and third iteration. Our interface group chat is only implemented in one class, that is Smack Group Chat. So it's one interface, one implementation. But now they are in different package. The interface is in domain layer, while the implementation is in data layer. If they are on different layer, you have to use interface or abstract class, no matter what, because that's the one usage of interface. To achieve polymorphism to be able to invert the dependency, so it will be data depends on domain and not the other way around. Now, so how do you design an interface? And based on our experience, there are two approaches. It's top-down or bottom-up. For both approach, we recommend for you to read open source code. You will learn a lot there. And then for top-down approach, first step is you create the concrete class first, and then you create and adjust the interface, and then you make the unit test. For bottom-up approach, you create the interface first based on your requirement, then you make the unit test, make it fail if it's necessary, and only then you implement the concrete class. And for both approaches, you obviously need to do refactoring when it's needed. And when you already have your interface, you have to think if it could be simplified or not. This is the fourth principle from Solid that we talked about before. Interface segregation principle. This principle says clients should not be forced to depend upon interface that they do not use. And as usual, this is a real example from KASKUS Chat. Previously, we have this one interface, chat credential, with these 4 contracts. Later, when we consume our own SDK, we realize that our third-party application doesn't need to care about these 2 methods, save chat credential and is logged in. It just doesn't make sense to them, because third-party apps should only care about giving the SDK, the username and password. In this case, the token. So we decided to apply this interface segregation principle, and we split it into 2 interfaces. The chat credential is defined in SDK and implemented in third-party application, while the credential pref is defined and implemented in SDK. We make it into an interface just so we could invert the dependency direction. Okay, last topic before we conclude this presentation. Keeping up with things that are not the Kardashians. It means keeping up with the latest technology. We will give you 2 examples. First, we used RX Java 1.0 on our first and second iteration for KASKUS Chat Android. And on October 29th, 2016, RX Java 2.0 was released, and the community decided that they will only support 1.0 until March 31st, 2018. So on December 2017, we decided to upgrade our RX Java library to 2.0. The second example, maybe this is the latest one, is Android Jetpack. It's a set of libraries, tools, and architectural guidance to help you build native Android app. I have not taken a detailed look on this Jetpack, but if you have a plan to create a native Android app, you definitely should check it out. And the bottom line for this is you should always keep yourself up to date with the latest technology. Okay, we are at the tail end. Let's recap what we have discussed. There are a lot of architectures in this world. We have Hexagonal, Onion, DCE, BCE, and Clean architecture. Maybe even more. We should not confuse ourselves between block and dependency diagram. Software was invented to be soft, remember? If you want it to be hard, just make hardware. And we learn about dependency inversion, inversion of control, and dependency injection. And we also learn their benefits. It's independent deploy and develop, and easily swap or upgrade our third-party libraries or frameworks. We learn about flow of control. We learn one way to implement clean architecture's flow of control. Remember, it's just one way to do it. maybe more. We know the difference between library and framework, and we also learn about SDK. We learn when we should be idealistic and when we should be pragmatic. We learn about one interface and one implementation. It's not overkill. We learn about steps on designing interfaces. That is, read open source code and then choose between top-down or bottom-up, and then apply the interface segregation principle. And finally, we should keep up with the latest technologies because, as the proverb says, what we learn or decide today will be obsolete tomorrow. And last but not least, as always, please use common sense. Every system is unique, every system is different. For those of you who actually made it this far, on behalf of Ping Android team, I would like to say thank you. Thank you for listening to this presentation. If you have any questions, criticisms, compliments, leave your comments below. And if you love this presentation, don't forget to hit subscribe and give your thumbs up. Thank you.